This video starts with a review. I'd like you guys to please go ahead and simplify number 1, simplify number 2, including the variable, and simplify number 3. Hit pause, try these 3 problems, unpause to check your work. So number 1, we should simplify to get 2 square roots of 2. Number 2, negative 4x to the 4th square root 2x. Remember, this negative that was outside stays outside. When I simplify my coefficient, 32, I get 16 times 2, or 4 times 4 times 2. Pair of 4s means pull one 4 out. Get rid of the other 4. I'm left with this 2. It's a leftover, it goes inside. With your variables from our previous video, we recognize that that is x to the 9th. If I have an odd exponent, I subtract 1 from it, giving me x to the 8th, but that 1 that I subtract, I just write outside. This x to the 8th, then, divide your exponents by 2. You don't factor tree your exponents, you divide them by 2, becomes your new exponent outside the square root. X to the 8th square rooted becomes x to the 4th. That extra x, that 9th x here, stays inside. Similar for number 3, I simplify square root of 50 to get 5 square root 2. The 4 was on the outside, so 4 times the 5 gives me my 20, and I have my 2 on the inside. X to the 7th became x to the 6th times x. That's my x to the 3rd outside, the x stays in. Y to the 11th is y to the 10th y. That becomes y to the 5th on the outside. Gotta bring that down with the y inside. This new video is going to be talking about multiplying coefficients. And we're also going to have to keep in mind that we're going to have to simplify at the same time, or in addition to. So, quick review, multiplying. When I'm multiplying my radicals, you can first multiply your coefficients of your radical. That means the number outside in front of the radical. I know this is a multiplication problem because it's multiplication in between my two terms here. Multiplying my coefficients means I can multiply 2 times 7. That gives me 14. Multiplying my radicand, which is the stuff inside the radical, that's my 6 times 3. 6 times 3 is 18. Putting this all together, I get 14, which was outside my coefficient. I get 18, which was inside my radicand. Lastly, simplify this new radical, just like we would have in our previous video. I have to simplify 18. Well, oops, good thing I already know one thing that I can simplify it by. 6 and 3. Because 6 and 3 got me 18, I can always go straight back to this term. Now I have 6 is 2 times 3 times this 3. I already know that I'm going to have 14 on the outside. I just have to determine what else goes outside. Well, I have a pair of 3s. I use one and get rid of the other. That 3 goes outside. The 2 is not used, it goes back inside, giving me a simplified answer of 14 times 3, 42 square roots of 2. That would be my simplified answer when I'm multiplying these two radicals. Okay, the other thing to keep in mind is when we are multiplying variables with exponents, we are adding those exponents. X to the 3rd times x to the 2nd is x to the 5th. 3 plus 2. But if I have my exponent outside of my parentheses, that's applying, and I'm multiplying inside. That's applying that exponent to everything in here. So that becomes 2x times 2x, which is the same as 2 times 2 and x times x, or 4x squared. Long way around just saying it's 2 squared and x squared. You do that if they're multiplying your terms inside here, not when you're adding. I don't do that if it was 2 plus x quantity squared. For that reason, if I have this, parentheses is what's being squared, square root 7 times square root 7, When I'm multiplying, I can multiply numbers that are inside. This gives me square root of 49, which is just 7. Again, let's talk about that. I'm multiplying the same thing. Or multiplying a number by itself, I'm multiplying square root of 7 by itself. In essence, what we're doing here, what we're saying is that this exponent and this radical symbol, that square root symbol, cancel each other out and leave you with just the 7. Okay. So we'll take a look at problems like that in just a couple of minutes. I'm going to do 3 examples with you, then you guys are going to work on some examples on your own. Example 1. I have a number times a number. Both of these are inside my square root, so I can multiply them. Shortcut number 1. Yes, 10 times 15 is 150. But the first thing you're going to have to do is start factor treeing. So when I'm multiplying and my numbers are both inside my square root, I just write it as a multiplication, because I'm going to have to factor tree these anyway. So I could have had another line in my factor tree saying 150, but then I would have gone down to 10 and 15, 2, 5, 3, and 5 anyway. I can skip that step. Now, pair of 5s, use 1, get rid of 1. 2 is left over, it goes inside. 3 is left over, it goes inside. Multiply 5 square root 6. There's my simplified answer. Number 2, same idea, but now it's mostly variables. This x and this x squared are outside, so I can multiply those, and x times x squared is x to the 3rd. Then, just like with number 1, instead of actually multiplying all this out, just write it down. 3x to the 3rd times 15x to the 7th. Now, let me take a step back. I would actually write down the coefficients inside, 3 times 15, this way. But for your variables, I would multiply them. X to the 3rd times x to the 7th is going to give you x to the 10th. The reason I do that is because now I see that I actually have an even exponent. Now let's be careful. This x to the 3rd is outside, so as I go to simplify, it's going to stay outside my square root. And I'm saying be careful because now inside I see I have an x to the 10th. That gets pulled out because it's an even exponent to give me x to the 5th. Not to mention, I have to keep factor treeing this 3 and 15. So let me give myself a little bit of space here. And I have this 3 times this 3 and 5. Now I have another thing that I have to pull out, a pair of 3s. So I bring this 3 out. What's left over? Well, I used all my x's. It wasn't odd, so my x's all got pulled out. This 5 is all that's left over. When I'm writing this all down, I do have to simplify these terms. So I get 3, because the number always comes first, coefficient first, x to the 8th times the square root of 5. And for number 3, the 2 is the only number outside. So the 2 is the only number that stays outside. Inside is 10 times 5. And then factor tree. 2 times 5 times 5. That's a pair of 5s. Use 1, get rid of 1. That 5 gets pulled out. The 2 stays inside. And this 2 was already outside. 2 times 5 is 10. square roots of 2. So I think numbers 1 and 3 here are not too bad. It's number 2 that's our really challenging problem there. As you flip to the next side, there are 6 problems to start. More practice. Go ahead and try those. You're going to press pause and try all 6 of them. Definitely try those hard ones, ones like number 5, 7, and 9, the ones that have your variables with your exponents. Unpause to check your answers. So hopefully you've tried the 3 even problems. Go ahead and check your work. Check your answers. Go back and check your work as well. I didn't factor tree down to primes because I knew where I'd get pairs, especially with something like number 6. I knew I'd get a pair of 6s. And number 8, I did go down to primes. If you have not tried those odd problems, please press pause and do that as well. Here's our first one. Our h to the second, h to the third being outside gave me my h to the fifth. H to the third, h to the fifth inside gave me h to the eighth. Since I have h to the eighth inside, that h to the eighth becomes h to the fourth outside. Add my exponents to get h to the ninth. So for number 7, when we multiply inside, we simplify, we get 14 times 7. Simplify, we've got a pair of 7s that we pull out. X to the ninth, because we have x to the fifth and x to the fourth. Okay, that gets split into x to the eighth and x to the first. 8x's in means 4x's out. That 1x gets left over inside. The only thing that gets pulled out are 4 of the 9x's inside. Okay, the other 4 get canceled out, and 1 stays inside. The last section on these notes is going back to the idea of multiplying a square root by itself. Okay? So we go back to the concept that square root of 10 times square root of 10, they're both inside, gives me square root of 100, which is just 10. Get rid of that square root. Okay? It's essentially saying square root of 10 squared, which goes back to my exponent of 2 cancels with my radical of 2, leaving me with just 10 as the inside. Number 2, just because I have variables inside doesn't change it. Okay? My answer is going to be xy. That's it. Because it's square root times square root, my square roots cancel, as long as everything inside is exactly the same. Go ahead and try number 3. If you said it's a squared b, you're 100% right. It's square root times square root, and everything inside is the same. We've looked at something similar to 4, 5, and 6 before, okay, but now we're adding that square root in there. What we have to recognize, this exponent of 2 here applies to these parentheses, and this exponent of 2 here applies to these parentheses. So the only thing being multiplied by that radical in number 5 is the square root of 6. However, in number 4, it's the whole thing. So the whole thing is getting squared. 2 squared square root of 6 squared is going to give me 4 times 6, or 24. Okay, because these are written next to each other, it's a multiplication problem. Whereas in number 5, this 2 is not being squared. It's not in the parentheses. It's just square root of 6 that's being squared. Square root and square cancel. That leaves 2 times 6, which is 12. Be careful with something like number 6, because this negative 2 is being squared, but remember, negatives need to be in parentheses. That is going to give me 4 again. And then I still have my square root of 6 being squared, which gives me 6. I get 24 again for this problem. Since this whole thing is in parentheses, this is the same as saying 2x squared. Well, that's the same as something like numbers 1, 2, or 3. I have an x or a square root being squared. My answer is what's inside. Different for numbers 8 and 9 though, because this g is not in the square root. I have to square the g, square the square root of h, giving me